Okay, guys, we're going to talk today about partial fraction decomposition. This sounds big and scary and ugly and awful, but it really and truly is not. And I'm going to show you exactly how to do it, how to work problems out, how to set up, and how to solve. So the idea behind partial fraction decomposition. Partial means not the total, just part. We're going to be dealing with fractions, and decomposition means to break down. So literally what we're doing is we're going to take a big rational function like this, and we're going to algebraically break it down into partial pieces like this. And you can check your answer, and I'll talk to you guys about this later. So again, this is the book definition on how we break down and partially decompose fractions. But in a sense, what we're going to do is we're going to break it down into a constant, which would be A, B, C, D, however many denominators you have. That's how many numerators or constants you have. And then a linear factor. A linear factor means you're going to take the denominator and factor it. So like we said, factoring is never going to go away. It's still here. So what you're going to do is factor the denominator, and then each different linear factor gets its own fraction. So since there's 3 linear factors here in the bottom, you have an A variable, you have a B variable, and you have a C variable. So in words, the first thing you're going to do is factor the denominator. Once you factor the denominator, you can then see what you're going to use to plug in for x's, and we'll talk about that. You're going to split the fractions for each term in the denominator, meaning each linear factor gets its own fraction. So you have A, B, C, and so on. And then you're going to find what would be the common denominator, and I'll talk to you about that in a second. You're going to find the value of x that would make each one cancel out, meaning you're going to set your denominator x equal to 0 and solve, and then you just do that over and over and over again. So let's look at some examples here, right? It says to find the partial fraction decomposition. First, we're going to show the setup, and then we're going to solve it. So the first thing you do is you factor the denominator. If you notice, this is already factored. So I have 2 linear factors, x minus 2 and x minus 5. So that means I'm going to use x minus 2 as one of my linear factors. And then I have x minus 5 as the other one. It doesn't matter what order you put them in. You can put x minus 5 first, no worries. And then I have A and I have B. If I had 3 linear factors in the denominator, then I would have 3 fractions. So now what we're going to do is we're going to set up. Before we solve, we're going to set up. So I'm going to say, all right, if I was going to get a common denominator between x minus 2 and x minus 5, well, we already know what that would be. It would be both of them together. So I'm going to multiply my A term by the piece it doesn't have, and then I'm going to multiply the B term by the piece it doesn't have. So what we've done is we've set up an equation here that is now equal. One left side is equal to the right-hand side. So your setup would be x minus 14 equals A times x minus 5 plus B times x minus 2. This is the setup. So on your quiz, you're going to have a couple questions that say set up, not solve, just set up. This would be your setup. And then how you solve for partial fraction decomposition is you take your linear factors in the denominator. You take your x minus 2 and you set equal to 0. You take x minus 5 and set equal to 0. And you find those x values, and then you evaluate. So I'm going to use x equals positive 2, and I'm going to use x equals positive 5. So we're going to solve this equation that we use right here that we have circled using x equals 2 and x equals 5. So the first thing I'm going to do is plug in 2 for x. So I have 2 minus 14 equals A times 2 minus 5 plus B times 2 minus 2. So now we simplify. 2 minus 14 is negative 12 equals 2 minus 5 is negative 3 times A would be negative 3A. And then I have 2 minus 2 is 0. B times 0, this will just cancel out. Divide both sides by negative 3. And your A equals negative 12 divided by negative 3 is 4. So we do the same thing over here on the right-hand side, but now I'm going to substitute in 5. So I have 5 minus 14 equals A times 5 minus 5 plus b times 5 minus 2. So 5 minus 14 would be negative 9 equals 5 minus 5 is 0, so a times 0, this cancels out. And then I have 5 minus 2 is 3, and 3 times b is 3b. Now we divide both sides by 3, and I get b equals negative 3. So what you guys should notice here is once you find your values that you're going to plug in for x, every time you do that, one of the other terms, or all of the other terms except for one, should cancel out. And what you have done is you've solved for the variables that go in the numerator of your partial fraction decomposition. So your final answer for this, you would substitute in your a here, and you'd substitute in b right here. So your answer would be 4 over x minus 2. Now you can say plus a negative, or you can just say minus. So I'm going to say plus, and then I have negative 3 as my b over x minus 5. And that is the solving part of your partial fraction decomposition. Now, if you wanted to check your answer, you can cross multiply. So watch what I do here. I say 4 times x minus 5 plus negative 3 times x minus 2. And you're thinking, well, what does that do? Well, let's watch. 4 times x is 4x. 4 times negative 5 is negative 20. Plus negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6. So now combine like terms. 4x and negative 3x gives me x. Negative 20 plus 6 gives me minus 14. So I got x minus 14. If you look back at your original problem, that's what your original numerator was. So this right here is the setup. If a question asks you to set up your partial fraction decomposition, that's what it looks like. And then here is the solving. So if it says to set up and solve, I need both of those pieces. All right, so let's look at number 2. All right, same thing goes here. First thing we're going to do for our setup is you have to factor the denominator. It's already factored. So how many pieces does your partial fraction decomp have? It has 2. It has 2 linear factors. So a is x minus 3, and then b is x plus 5. All right, so this is the setup part. We're going to get everything all set up, and then we'll solve. So the first thing we do is multiply by the factor that the fraction does not have. So x minus 3 is here with a, so I'm going to multiply by x plus 5 for a. And on the other side, b has x plus 5, so I'm going to multiply by x minus 3. So we now have the setup part of our partial fraction decomposition. You have 6x plus 14 equals a times x plus 5 plus b times x minus 3. Okay, that's the setup. When you're asked to set up the partial fraction decomposition, this is what we're looking for. Now, in order to solve it, you have to figure out what you're going to use for x values. So if you set each linear factor equal to 0, x minus 3 equals 0, this will give me x equals 3, and x plus 5 equals 0, this will give me x equals negative 5. Now, in order to solve, you evaluate your setup with each x value. So here I'm going to use x equals 3, and here I'm going to use x equals negative 5. So I have 6 times 3 plus 14 equals a times 3 plus 5 plus b times 3 minus 3. So as we go through and simplify, 6 times 3 is 18, and 18 plus 14 gives me 32 equals 3 plus 5 is 8, so 8 times a is 8a. And then what do you have when you have negative 3 and positive 3? It's 0, so this cancels out. Divide both sides by 8, and your a is 4. No. All right, so now I'm going to do the same thing over here, but we're going to substitute in negative 5. So 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 minus 3. So 6 times negative 5 is negative 30 plus 14 gives me negative 16 equals negative 5 and a positive 5 is 0, and 0 times a gives me 0. And then I have negative 5 minus 3 is negative 8, so b times negative 8 is negative 8b. Divide both sides by negative 8, and I get b equals 2. Now we're not done here. We're almost done. But we now have to take our a and b value and plug it into our setup up here. So I'm going to, instead of a, I have 4 over x minus 3 plus b is 2 over x plus 5. So there's the solving part of our partial fraction decomposition. And again, if you want to check, just cross multiply. We're going to cross here and here. So I have 4 times x plus 5 plus 2 times x minus 3. So 4x plus 20, and then I have plus 2x minus 6. So 4 plus 2 is 6x. 20 minus 6 is positive 14. And if you look back to the original problem, 6x plus 14 was our original numerator. Okay, a couple more. Let's go through here. All right, if I look at this problem, I want to set up and then solve. So the first thing we need to do is factor the denominator. If you guys notice, this denominator is not factored for us. So we're going to go back to our factoring that we did at the beginning of the year. First thing we look for is GCF. Do you see a number and or letter that goes into all three of these? Yes, we do. Everything divided by 2. So I bring out the 2 out in front, and I'm left with x squared. 6 divided by 2 is minus 3x, and 80 divided by 2 gives me minus 40. So now I say, okay, are there two factors that multiply to give me a negative 40, but add to give me negative 3? So it'd be x minus 8 and x plus 5. If I'm going to go ahead from this point and solve to see what x values I'm going to use, set each piece equal to 0. So x equals 0. Negative 2 equals 0. X minus 8 equals 0. And x plus 5 equals 0. So here, doesn't make sense. We can cross it out. We're fine. Here we're going to use x equals 8. And here we're going to use x equals negative 5. So I only have 2 denominators here. I have 2 linear factors because that 2 we factored out. It's just a number by itself. If it had an x with it, then we would leave it as another denominator. But it doesn't, so we're good. So I'm going to write here, my first linear factor is going to be x minus 8. My second linear factor is going to be x plus 5. So I have a, and I have a b. So now I say, okay, what do I need to multiply the opposite by? So a has x minus 8, it needs x plus 5. B has x plus 5, it needs x minus 8. So our setup is going to be x plus 3 equals a times x plus 5 plus b times x minus 8. So there's our setup. So if the question asks just for the setup of the equation, that's what we're looking for. That's the setup. And now in order to solve it, we have to use our 2x values. So we're going to solve using x equals 8 and using x equals negative 5. So let's come down here. So x equals 8. And over here, x equals negative 5. So I have 8 plus 3 equals a times 8 plus 5 plus b times 8 minus 8. So 8 plus 3 is 11 equals 8 plus 5 is 13, and 13 times a is going to give me 13a, plus 8 minus 8 is 0, so this is just going to cancel out. Divide both sides by 13, and I get a equals 11 over 13. Now, same thing, we're going to evaluate using x equals negative 5. So I have negative 5 plus 3 equals a times negative 5 plus 5 plus b times negative 5 minus 8. So negative 5 plus 3 is negative 2. Negative 5 and positive 5 is 0. This will just cancel out. This gives me negative 13 times b gives me negative 13b. Now, divide both sides by 13. Negative 13, I'm sorry, and b equals positive 2 over 13. So for the solving part, guys, remember we go back to the original and then we replace our a's and b's and c's and however many letters we have with the values that we found. So I have a is 11 over 13 over x minus 8 and then I have plus b is 2 over 13 over x plus 5. And if you notice, guys, we have a fraction in the numerator. So what you do in order to write this as simplified as possible is this denominator, this denominator at the top just moves to the bottom. So you would rewrite this as 11 over, and you can leave the 13 on the outside. You don't have to multiply it in if you don't want to, but if you do, that's fine. So then I have 2, and then I have my 13 on the bottom here. So you can leave it just like that for your solving. And again, if you wanted to check, cross multiply and go through the whole deal here. But if you do end up with a fraction as your a or your b, just move the denominator of that fraction to the denominator of the whole problem. All right, and lastly, we're going to do this one. Again, we're going to set up and then we're going to solve. So the first thing we need to do is factor, guys. We're going to factor. Do you see something that these have in common? X squared minus 4x. Yes, they both have an x. I'm going to take that out, and that's going to leave me with x minus 4. So again, I have two denominators here. One of my denominators is going to be x, and the other one's going to be x minus 4. So I have an a and a b. I'm going to go ahead real quick and just solve, see what values I'm going to plug in for x. I have x equals 0, and I'm going to use x equals positive 4. Because if we set x minus 4 equals 0, you get positive 4. So we now say, okay, my a has the x. It needs x minus 4. My b has the x minus 4. It needs x. So now we're going to go through and set up our equation. We have x squared plus 12x plus 12 equals a times x minus 4 plus b times x. So we're going to evaluate this setup. This is my setup. This is my equation setup that when they ask you for the partial fraction decomposition equation setup, that's what we're looking for. Now I'm going to evaluate where x is 0 and where x is positive 4. So when I plug in 0 here, I have 0 squared plus 12 times 0 plus 12 equals a times 0 minus 4 plus b times 0. So 0 squared is 0, 12 times 0 is 0, so I have 12 equals 0 minus 4 is negative 4 times a is negative 4a, and b times 0 just cancels. So we divide both sides by negative 4, and a equals negative 3. All right, we're going to do the same thing on the right-hand side, just solve with 4. So I have 4 squared plus 12 times 4 plus 12 equals a times 4 minus 4 plus b times 4. So 4 squared is 16 plus 12 times 4 is 48 plus 12, which when I add 16 plus 48 plus 12, I get 76. And then 4 minus 4 is 0, so this cancels out. And then I have 4 times b is 4b. So we have 4b here. 76 divided by 4. Divide both sides by 4. And I get b equals 19. Now we're almost done solving. We have the setup part done up here. Now we have to go back and solve. So I'm going to replace my a and my b with the numbers that I found. So a is negative 3 over x. Plus my b is 19 over, what was x minus 4? And that is the solve part of your partial fraction decomposition. So in class, guys, I need you to submit your notes from this week, from this video, submit them into Canvas by 8 o'clock Monday morning. And then Monday and Tuesday, we will go over a bunch of problems just practicing this.